Welcome to problem of the day 114. Solve the problem using the definition of a derivative. So we got our original function f of x equals square root of x, and then our definition of a derivative is f prime of x equals the limit as h approaches 0 of f x plus h minus f of x all over h. So what we'll do is the hardest part is the setup, and you'll plug in the original function here into the formula, and you'll have the limit as h approaches 0 of the square root of x plus h. So you just trade out this x for x plus h. So that's what you're swapping out there, and then it's minus the original function, which is the square root of x all over h. And then what we can do is multiply by the conjugate. So the multiplying by the conjugate, you have the square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. And then you'll end up foiling everything over, and then you'll have this in the denominator of the h times what I stated before of the conjugate. And then we'll end up foiling out, and we'll get like terms. So the x's cancel, and then we'll get these two terms to cancel as well. So you end up with the limit as h approaches 0 of h, so the only thing on top is h, over h of the square root of x plus h plus the square root of x. So then we can factor out an h again here like we did yesterday, and you get 1. So then you're left with 1 on top, and then just the bottom numerator of the conjugate. And then you can plug in your limit statement, so the h turns into 0. So then you end up getting square root of x plus square root of x, and that's all in the denominator. So then it simplifies to 1 over 2 square root of x, and then if you check it with the polynomial rule, you'll actually get the same answer too. So I hope this helps.